Hey boys and girls, checking in for week 5 main ideas, and we're finishing up in our New York Progress Orange Book and our Word document that you have working. So you're going to have your Orange Book in front of you, split screen. One is obviously the video of me, and the other one is the Word document that you are working on. And if you go all the way down to your document, you'll see the last 2 topics today that we're going to do. One is called plate collisions and mountain ridges. And we're going to have 2 main ideas. That would be paragraphs 13 and 14, and then we'll have making predictions. And that could be found on page 66. Plate collisions and mountain ranges. Collisions in plates also result in the creation of mountain ranges. While the bottom plate is forced downward, the top plate is pushed upward. So earthquakes occur at the boundaries between plates, and so do many of Earth's mountain ranges. Just think about how much energy this takes. And I want you right now to pause the video. Sometimes the author tells you the main idea right in the text. It's in there. So pause me, see if you can find that main idea. Okay, so the main idea we have is simply, just typing in, I'll write mine in here. Whoops. Mountains created or mountains made, or how mountains are made or created. Okay, so now let's go into paragraph 13 and let's see if we can find our 2 details that really hone in and key in on us and tell us how mountains are really created. Pause me and then unpause me when you have both your details filled in. Okay, so hopefully you have something in there, boys and girls. Again, pausing me like you would in this classroom. I know it's going to take longer than the video because you got a couple minutes, 30 seconds in between to figure out your answer. So your first one you should have where the bottom plate is forced down and the top plate pushes up. So I'll hold that in front of the screen there, my sloppy handwriting. So the bottom plate forced down and the top plate pushes up. And you can almost simply do that with your hands. So if your hand is one plate, here's another plate. Okay, so we have, what do we say? The bottom plate is forced down. So as the bottom plate is going down, look what's happening to my fingers. They're going up. So again, keep your hands nice and rigid. You can do this on your own. The bottom plate, push it down. Look what happens to their fingers. They bend, therefore creating that energy and making, obviously, my hand. Looking at this hand right here, watch how they go up. So I'm putting, and it's moving up. Okay, same thing. It's a little harder to do with paper here, but it'd be the same thing. So if I have these plates, one gets stuck, one pushes down, watch what happens, boom, pushes it up. It's a little harder because it gets caught there. There we go. See how that pushes up? So this is my plate. Let's say it catches it, and it therefore makes that mountain become larger. Okay? And then your second detail. See if you can find your second detail. If you don't have that second detail in just yet, make sure you have that. Pause me if you need to. All right, I have lots of energy. So can you imagine the amount of energy that it takes for mountains, land to just crush and crumble and be pushed upwards? And that's where a lot of mountain ranges happen. Lots of energy for that to happen. So plate collisions and mountain ranges. So when these plates are colliding, that's how mountains are created. They literally, do it with your hands, form together, and look what happens. They kind of, your hands literally bend, the one comes up, okay? Or you can do both, where they both form together, and you're both going up, okay? Let's go to paragraph number 15. The highest mountain range in the world, above sea level, that is the Himalayas. The Himalayas were formed when 2 plates collided. These plates are still colliding today. Because of the collisions, the Himalayas continue to rise a small amount each year. All right, pause the video. You know the drill. Find me the main idea in paragraph 14. All right, you unpause me, and I think this one is a little one of our easier ones. What is the topic that we are talking about? Plate collisions and mountain ranges. And this gets into real specific, a main idea.
Great job. You may enter the building.
Himalayas. That's all they're talking about in paragraph 14 is the Himalaya Mountains. All right, so now let's pause the video again, go back and find out what details are in that text just from paragraph 14. I have you on pause now. Thank you. We have the highest mountain range in the world. That's pretty important, the Himalayas. I have them being the highest mountain range in the world. And I have how they were formed. Formed where two plates collided. Boys and girls, the Himalayan mountains is exactly where you will find Mount Everest, the Himalayas. Okay, so very good job on this. This is our plate collisions and mountain ranges. So we learned about how mountains were created. We talked about the two plates colliding. One plate pushes up on the top plate. Loads of energy for that to happen. And then we just were introduced to a group of mountains called the Himalayas. It's the highest mountain range in the world, and they were formed when two plates have collided. And that leads us to our very last one of making predictions, and that will be paragraphs 15, 16, 17, 18. So let's get right into it. Paragraph number 15. Plate tectonics is an important area for scientific study. Scientists observe movements in the plates. What they learn helps them understand how parts of our planet are changing. They also can consider what Earth might have looked like long ago and make predictions about what it might look like in the future. This one's a little harder main idea, but it does kind of hint at what they're talking about. So pause the video, see if you can attempt what that main idea is. Okay, now this one is a little tougher. Like I said, this one doesn't really tell us the answer right away. I have plate tectonics. And plate tectonics is that fancy word of scientific study. Plate tectonics, and I wrote the word study down. So what they do, what we're learning about is this thing called the study of plate tectonics. And then let's go back. We'll do this together. Let's go back in that and look for our details. So I'm going to reread this one. Plate tectonics is an important area for scientific study. See, they kind of gave us the main idea there. Thank you. Scientists observe movements in the plates. What they learn helps them understand how parts of our planet are changing. That's pretty good right there. So we want to say how parts are changing. For our first detail, how parts are changing. And then let's look for our second detail. They also consider what Earth might have looked like long ago and make predictions about what it might look like in the future. So I've got predict how it looked, and then I also have what it might look like. So there's my paragraph 15. It's about the study of plate tectonics. That's why I wrote the word study. How the parts are changing. How everything is changing in our world with those layers and everything. And then they predict what the world once looked like and what it might look like in the future. All right, so that leads us now to paragraph 16. Plate tectonics can also help scientists better understand earthquakes. Are you there? Because I think I just heard a main idea. That's pretty easy, right? Yeah, I got it too. Don't get this one wrong. Scientists observe where and how the plates collide with each other. That information helps them watch for earthquakes in those areas. It also can give people who live near plate boundaries warnings about when the next earthquake might occur. Pause the video, come back, and you better have that right answer. All right, I don't know if you guys got this one. This one was so hard. Just kidding. It helps them understand earthquakes. The author literally came out and told us. Sorry, I'm squeezing it in here with my yellow. Helps us understand earthquakes. All right, now let's go in the group and figure out how they help us understand earthquakes. They observe how they collide, how plates collide. And what does this do? This tells people where and when. So obviously, if you're out in California by the San Andreas Fault, they're observing that fault line very much so. So they know, this is not they know when the next one might occur because there hasn't been a big one in a while. Usually that's kind of like a sad thing with earthquakes. They expect a big one to happen because it hasn't happened in a while or something like that. And then the last one, go back into the text here, understanding earthquakes. Paragraph 16, what does it do? It helps us do what? Give people warnings. All right, so understanding earthquakes, we observe these plates and they collide, tells us where and when. So what purpose does that give? It helps us give people warnings like, hey, if you're living in California, better buy some earthquake insurance for your company. Better make your building able to withstand an earthquake versus here in New York. We don't have to worry about such things. Okay, our last main idea. We're on the last page, 17 and 18. And this one is a little tougher to do. Not as easy as 16. 16 is pretty easy. He came out and told us. The study of plate tectonics allows scientists to look at the way landmasses once fit together. It also indicates how Earth has changed over time. Scientists can identify where pieces of crust are new. They can discover where older pieces of crust are located. Since oil and gas come from very old rock, scientists have learned that they do not need to search for oil and gas in areas where the crust is new. Newly formed crust, however, has many minerals that rise to the surface. Perhaps these minerals will become new sources of energy. Through plate tectonics, we can someday find new ways to work with the amazing energy of our planet. And you remember paragraph 1 back in class? We didn't really have a main idea for that because it was like an intro paragraph of what we're going to learn. This last sentence there, it's pretty much our conclusion. Through plate tectonics, we someday find a new way to work with the amazing energy of our planet. So that one's not going to be really a detail, but let's look and see what paragraph 17 and 18 I have. How Earth is and was. So this is telling us that using our study of plate tectonics, we can focus on how Earth used to be and how it is right now. Okay, so the main thing about making predictions, we use plate tectonics to study. This is what it's about. This is the understanding the earthquake, and then it also tells us a lot about the past and about our land masses. So I have land masses fit together, and this goes back to the very first thing that I showed you in class. Remember that when I told you how things will fit together like a puzzle piece? It has a fancy name. It's called Pangea. That's what people called the world when it was millions and millions and millions of years ago, when all these puzzle pieces were together. Now we know the answer, that the land masses once fit together, and it was because, see if you can think about it. Don't just say plate tectonics. See if you can answer that question right here and right now for me. What made all of these things separate? And I'll go back to you. I want you to go back to the most important thing that we came across. And it's that word. And remember? The Mid-Atlantic Ridge. Did you remember how important that was? The Mid-Atlantic Ridge. And I'll show you when we come back in class. But the Mid-Atlantic Ridge, boys and girls, runs all the way through the ocean. And we'll show you exactly right on page 62. And I'll show you in class it's easier to do right next to you. And I'll show you how that Mid-Atlantic Ridge literally looks like the North American plate and the Pacific plate, excuse me, not Pacific, how the African plate and the South American plate literally were once fit together. And that mid-Atlantic ridge, if you remember, it's where slowly new formed crust, millions and millions and millions and millions of years, that newly formed crust. Well, look at my hands. My hands are doing what? They're going further away. So that's what North America and our, Asia, we were close together. Now this mid-Atlantic ridge, they're getting further apart. Same thing with South America and Africa. They fit together like a giant puzzle piece, and then they're getting pulled further and further apart. Okay, so that's how land masses once fit together. And then they have the new crust. They find new crust. So how our Earth is, they'll find the new crust. And the important thing about them finding new crust, they can easily tell where the plate tectonics, are, where they're kind of meeting. And we know obviously the Mid-Atlantic Ridge, that's where we're finding new crust all the time. And then the last one, they don't search for oil or gas in new crust. It's called fossil fuels. I don't know if you guys knew this about our gasoline, but it's called fossil fuels. So if you think of a fossil, it is rock, or obviously in this case could be even dinosaur bones, that have been submerged and pressurized that they become gas particles. And people dig for oil, they extract that from the earth. So they know they're not going to search areas that have new crust. So they're going to find where the new crust is, and they're not going to go search down there for oil because they know that's not old. They got to find old land so they can be able to find some of that gas and some of that oil. Okay, boys and girls, that is it. I know this video is a little bit on the longer side, but we had 2 topics to do today. Everything that you filled in is going to be your grade. Now your grade should literally just be a 100. Hopefully you finished. If you need to go back and do those, but just submit now. Now we're on day 5. You did it. You are on week 2 of our main idea, week 5 overall. Super proud of you guys. This was not an easy story. This was not an easy concept at all. And that's what happens when we learn new things. We've got to kind of slow down our comprehension and make sense of them. And you saw me using my hands and thinking of things to connect them to you. I showed you a lot of videos in class. And we'll do a little bit more when you guys come back, and I'll have you guys as kind of experts already on Earth's layers, so then we can talk about them a little more, and you can be a little more, you have a little more background knowledge in the back of your head, because you obviously have done these videos. Well, take care, guys. Great job.